This lesson is on volcanoes. Most often when we think of a volcano, we think of a large mountain spewing forth lava and smoke and erupting. But in reality, a volcano is any opening in the Earth's crust where magma occasionally exits. It doesn't have to be this large mountain. Okay, it can be something as simple as a hole in the earth, or it could be like a fissure volcano, which is like a crack in the earth. It doesn't necessarily have to be a large mountain. Now, a small vent or hole where magma exits can eventually build up in one of these big mountains, as we're going to talk about. But any place in the Earth's crust where magma or lava can exit is considered to be a volcano. Now, volcanoes are associated with divergent plate boundaries, convergent plate boundaries, but not with transform boundaries. That's something that we mentioned in the plate tectonics lesson, but should be reiterated now. All right, let's talk about the types of volcanoes. The first one we'll talk about here is shield volcanoes, which form when lava quickly pours out of a vent and accumulates around the vent. These are the biggest volcanoes, but they are the least explosive type. These are not likely to explode and erupt very violently, but the danger with them is that the lava that flows out of these is very runny and will easily flow and can flow very quickly. All right, shield volcanoes have very broad sides, such as you see in the picture there. So they're not necessarily the tallest volcanoes, but they are very broad. Shield volcanoes are most often found in Hawaii. For the most part, you could consider the Hawaiian Islands themselves to be large shield volcanoes. All right, the second type is the cinder cone volcano. These form when rock fragments shoot out of a volcano, fall back down, and accumulate around the vent. So like I was saying earlier, a volcano can start out as simply a hole in the Earth's crust, and this is how these cinder cones form. You have this vent or hole in the crust. All right, these rock fragments shoot out in an explosion, and then they fall right back down, and they accumulate around the vent along with lava that pours out, and they create a cinder cone volcano. Now, these are the smallest type of volcano, but they're actually more dangerous than the shield volcanoes, despite the fact that shield volcanoes can be much larger. All right, cinder cone volcanoes have the steepest sides of any volcano, hence the name cinder cone, as they can be quite cone-shaped. So they have steep sides, which lava can flow down rather quickly. All right, but unlike shield volcanoes, cinder cone volcanoes can be explosive. All right, and the third type we'll talk about here are composite volcano or stratovolcanoes. So these form at convergent plate boundaries where you have a piece of Earth's crust going under another piece, subducting under another one. And you have the subducting plate melting rock and pushing magma through the crust above it to form a volcanic mountain. These are the most dangerous types of volcanoes because they are very, very explosive. And we'll talk in a moment about what makes one volcano explosive while another one might not be explosive but instead have really runny lava. Okay, composite volcanoes, like I said, are the most dangerous type. Many are located along the Pacific Ring of Fire, which I'll show you on a map in a moment. One of the most famous examples, at least here in North America, is Mount St. Helens. All right, hot spots are unusually hot regions of Earth's mantle where magma occasionally rises to the surface and forms a volcano. So these are volcanoes that are not located on a plate boundary. These can occur in the middle of a plate. The Hawaiian Islands were formed by the Pacific plate moving over a hot spot, such as you see in the picture. In this picture, you see these arrows, and they indicate that the plate is moving in that direction. Okay, and what's happened here is as the plate moved in that direction, the hot spot, the magma from the hot spot punched through the crust and formed this volcanic island chain. Okay, so this island was once over the hot spot. All right, so this volcano formed into this volcanic island, and then as the plate moved this way, this island was the next to form, and as the plate continued to move that way, this island was the next to form from the hot spot, and then currently this island has formed from the hot spot. Okay, so the oldest volcanoes are going to be the ones furthest from the hot spot, and the newest ones are going to be the ones closest to the hot spot. And here we have the picture of Hawaii, because Hawaii is a volcanic island chain formed from a hot spot. Here we have a picture of a caldera. This is another kind of volcano that can be caused by a hot spot like this. The Yellowstone caldera is the best known in North America. And here's a picture of a caldera that is not currently erupting but has erupted in the past. And you can see this one's quite large. You actually have some lakes and ponds and mountains inside this large caldera here. Alright, magma is molten or melted rock that is stored below the Earth's surface. Once magma reaches the Earth's surface, it is then known as lava. Okay, so that's the distinction between magma and lava. Alright, if it's below the surface, it's called magma, and if it's above the surface, it's called lava. The material is really no different. It's just they have different names that indicate where they are. Okay, magma below the surface, lava above the surface. Alright, let's talk about magma and viscosity. Like I said earlier, now we've got to talk about what makes one volcano very explosive while another one is not very explosive. It all has to do with the magma's viscosity, or its resistance to flow. Okay, so you've probably heard of viscosity before if you've ever seen a motor oil commercial. They're always talking about viscosity on the motor oil commercial. Alright, so the higher a liquid's viscosity is, the slower it moves. Okay, so you can think about something like a really slow flowing substance. A lot of times they use like syrup, like you would put on your waffles or pancakes, as an example. It flows very slowly because it's quite viscous. Okay, an example of something that is not very viscous at all is water. Water flows really easily and readily. Okay, so the higher a liquid's viscosity is, the slower it moves. Alright, high silica content, alright, or felsic magma equals high viscosity. Okay, so the more felsic the magma is, the more viscous it is, the higher its viscosity is, and the more resistant to flowing it is. Alright, low silica content, or mafic magma, is going to have very low viscosity. Okay, so the more mafic the magma is, the more easy it is for it to flow. Okay, so the high viscosity felsic magma that cannot flow very well is going to produce greater volcanic explosions. Because the magma cannot flow well, it does not escape from the volcano very easily, so the pressure really builds up until you have an explosion. On the other hand, the low viscosity mafic magma produces little or no volcanic explosions because it can flow more easily. It's easy for it to escape from the vents on the volcano, and it will flow, and the pressure does not build up and create large explosions. And we have three levels of viscosity for magma. Okay, we have rhyolitic, which is the most explosive. That's the most felsic magma, rhyolitic. Andesitic is kind of intermediate. It's in the middle there. It's the second most explosive, but it's not as felsic as rhyolitic magma. And then we have basaltic magma, which is very mafic. It is not very viscous, so it's the least explosive type of magma. So this explains why some volcanoes are very explosive, while others are not very explosive. It all just depends on the silica content or the metal content of the magma inside the volcano and how viscous or not viscous the lava is, how easily it flows or how resistant to flow the magma is. All right, 3 stages of volcanic activity. All right, an active volcano is a volcano that is in the process of erupting. That means it has gases, smoke, ash, lava coming out of it. One or more of those things coming out of it right now. That's an active volcano. A dormant volcano is one that is not currently erupting. It doesn't have anything coming out of it, but it still has volcanic activity occurring under the surface and may erupt in the future. All right, and then we have extinct volcanoes. Now, a lot of times when we think about the word extinct, we think of something that doesn't exist anymore. You can't see it. It's not here anymore. But in the case of an extinct volcano, you could still have that mountain there, okay? But it is not likely to ever erupt again because either the volcanic activity under the surface is declining, it's getting weaker and smaller with time, or it's already totally subsided and is no longer existent. There's no more volcanic activity under the surface, and now you're left with just plain mountains. Okay, so an extinct volcano, at that point, it's more or less just a regular mountain at that point. All right, pyroclastic flow and ash in the atmosphere. Pyroclastic flows, which are sometimes known as stone winds, are violent volcanic eruptions that send ash and rock fragments down a slope at incredible speeds. These flows are very hot and contain poisonous gases. So if one of these were to roll over you, even if you didn't get burned up by it or bombarded with rock fragments, the gases it carried could suffocate and kill you. Okay, so these are very dangerous. Also, ejected ash from this pyroclastic flow can block out the sun and cause short-term climate shifts. And this has happened many times. Okay, so it can block out the sun and actually cause a period of cooling to happen. And you know how widespread this climate shift is just depends on how large the eruption is. Okay, a smaller eruption in which ash blocks out the sun could cause just a regional climate shift. But a big enough eruption could cause a global climate shift and cause a period of cooling. And in fact, in the past, there have been eruptions large enough that the world experienced what they call a year without a summer. All right, a lahar is a mud flow caused by volcanic activity. So sometimes you have volcanoes that have glaciers on top. And when those volcanoes erupt and release all that heat and the magma flows out, the lava flows out of it, it can melt the glaciers on top of the volcanoes and send all this water down the hill or down the slope. All right, so then that water rushes down the mountain and it picks up sediment along the way. And then if the water has enough force, or there's a combined force with all the material that it's picked up, it can knock down trees and carry other things down the slope. All right, so the more the more material it picks up, the stronger it gets. And so this is a whole other agent of destruction that can be caused by volcanic eruptions. All right, here is another picture of the tectonic plates, and you can see here each red dot represents a volcano or volcanic activity, and you notice that they are very often located right along these plate boundaries. All right, and especially when you look at the Pacific Ring of Fire here. Okay, you've got this ring of volcanoes all the way around this long boundary here. All right, and over here. Okay, this is what we call the Pacific Ring of Fire. But notice All right, we do also have these hot spots. We have some of these areas of volcanic activity that are not on plate boundaries. Okay, so keep that in mind. Not all volcanoes are on plate boundaries, but they do most often occur along convergent and divergent plate boundaries. Mount St. Helens, like I said, is one of the most famous examples of a very destructive volcanic eruption here in North America. Right, Mount St. Helens is part of the Cascade Range of mountains, which is part of that Pacific Ring of Fire. On May 18, 1980, Mount St. Helens erupted. It's considered to be the deadliest volcanic eruption in the history of the United States. It killed approximately 57 people, destroyed over 250 homes, and countless animals and habitat were lost due to this eruption. Now, if you were to go to the site of the eruption today, you would see that nature is kind of taken back over again. Okay, it's getting green again, and it's kind of rejuvenating. But immediately after this eruption, the landscape looks similar to what is produced by an atomic explosion. It's very devastating. You'll be able to see that in the supplemental videos that I've included in your lesson.